Hi guys, I hope everybody's doing great. I'm happy to see you again. So today, as I promised, we're going to look at one of the concepts in mathematics. Although as I mentioned that it's part of mathematics, we are going to see that it's going to find some of the wide applications in physical sciences, especially in areas of physics like the theory of waves, and then oscillations and vibrations, and sometimes in alternating currents that we're going to look at under the topic of electricity. So in this case, we're going to look at ways in which we can be able to represent different trigonometric functions on a graph. And basically for today, we're going to limit ourselves to two basic trigonometric functions for the sine and the cosine of theta. So without further ado, thank you and welcome. So as I've said, today's topic is basically going to be one of the ways of trying to find how we can represent different angles of trigonometric functions on a graph. And as we said from our earlier videos, the concept of graphing basically entails perhaps representing or having a pictorial representation or a diagram that is going to represent data or values in an organized manner. So therefore, as we said, for the basic graphs that we normally encounter in mathematics, they have, of course, from the rectangular axis or the rectangular coordinate system, we said that we have two different ordinates, which are going to form a pair that we refer to as a coordinate. So therefore, suppose I just represent a point on a graph like x and y for the general representation, then therefore this is going to represent what we refer to as a coordinate. So therefore, in our discussion for today, we're going to limit ourselves to the concept of a rectangular coordinate system, which is going to assist us in interpreting how we can be able to represent trigonometric functions using the relationship between a unit circle, the graph, and then the different angles that I've given in this specific stretch. I'm going to illustrate on how these specific parts for the first, second, and third one are going to assist us achieve that. So therefore, starting from this point, I've assumed that in this particular range, we have got different values for degrees. And in my case, I've given an interval for 45 degrees, ranging from one unit to another to a stretch of 360 degrees. So therefore, if we try to look at this particular stretch, therefore it's going to represent this particular full cycle. And we said that for us to represent this range of a full circle, we can use this unit circle, which basically is going to contain also the x and y coordinate which runs through the center that I've referred to as O. So therefore, at this specific point, as I've said that this represents a unit circle, we're going to have an extension of one unit along the x-axis and y unit along the y-axis, and their respective opposite unit points. So therefore, these are going to assist us illustrate on how we can be able to, of course, represent these angles in a cycle in terms of a graph. And lastly, we're going to look at this last bit, which is going to assist us find the values for different angles. Now, specifically for my values of x, I'm going to use these angles that I've listed in this lower part of this specific graph. So therefore, for us in interpreting this, at this specific point of the graph, starting from this 0 degrees, we're going to have our unit or the starting point for us, the origin at this specific point, whereby this negative extension is going to represent negative unit, and then the positive is going to represent positive unit. And these specific points have indicated 0.5 for half of that stretch, respectively. So therefore, as I've said, this is going to assist us in interpreting some of the concepts we're going to encounter in theories of waves, AC currents, and some of the vibrations and oscillations that we're going to encounter in physics. Now, going forward, from this concept of a circle that I've mentioned, I'm going to assume that we have the basic, of course, knowledge on the concept of a circle. And therefore, I'm going just to have a small recap of what we need in order for us to understand this concept. Now, from this point, whenever we're trying to talk about the concept of angles, we're going to see that for a circle, the angles are labeled in an anti-clockwise direction, whereby we're going to have the angles increasing from this specific point in an anti-clockwise direction until we finish a full cycle. Now in this case, as I've said, we're going to have a relationship that exists between this angular extension and then the coordinate system. So therefore, as the angles stretch from this particular point, there's going to be a specific point whereby we're going to have a specific extension for the x and y axis, which of course we are going to, just because of space, just have a mention. So therefore, if I talk of the stretch of 45 degrees, then therefore we'll be having that angle assuming a specific extension for the x-axis and the y-axis respectively. So that is going to give us a relationship that exists between the angles and those two stretches for x and y. And we say that the ratio between the x and y, and of course we can just give this one as z for the right angles for the opposite, adjacent, and hypotenuse. Those ones are going to give us value for the trigonometric functions. So therefore, this specific point for the y-axis, that is going to be at this specific point, this is going to give us the values along the y-axis, which are going to represent values for these different trigonometric functions. So therefore, suppose I try to represent this range of angles that I've given along this lower line. We're going to have 45 degrees at this specific point, and then this is 90 degrees, and then from there we are going to have this approximation, and then we are going to have 135 degrees at that specific point, and then we are going to have 180 degrees at that specific point, and then an addition 45 degrees from 180 is going to give us 225 degrees. And then at this specific point, we're going to have 270 degrees. And then we can just do a plot of the remaining one for 315 degrees. And then lastly, a full cycle is going to contain 360 as illustrated above. So in that case, that is how we're going to just try to figure out how to represent that. And as we have said, for us to define the values of these trigonometric functions, we're going to see that the x and y coordinates of these corresponding points, as I've mentioned, are going to give us the values for the degree, and then the value for a respective trigonometric function for the sine and the cosine of theta. Now, as we proceed, we're going to see that for n2 angles that are going to differ by a multiple of a full cycle, which is 360 degrees, the values of their trigonometric functions for the sine, the cosine of theta or x are going to be the same. So that's going to be elaborate whenever we're trying to, or rather when we're going to complete this specific graph that I've drawn on the lower part of the board. So therefore, we're going to see that whenever the values for the sine and the cosine of theta are going to be represented as I've already mentioned. So therefore, as I've said, the main point for us, we're going to see at the end of our discussion that, as I've said, for the n2 angles that differ by a full cycle, that is 360, are going to have the same values. So this nature of recurring of 360 degrees as we add, or as the angles accumulate by a difference of 360 or a full cycle, is going to be referred to as the concept of periodicity. Therefore, we are going to see that the function for the sine and the cosine of theta are going to be referred to as a periodic, and therefore it's going to give us a clue on some of the, of course, applications that we have already mentioned on these two specific trigonometric functions for the sine and the cosine of theta. So therefore, we're going to go ahead and try to see how we can be able to do a plot of those specific trigonometric functions and see the relationship that exists between them. Now, I'm assuming that from the basic concept of trigonometric that you have discussed in our earlier videos, we are fully aware of the concept of this acronym that we have been using for the three basic trigonometric functions. Now, in our case for today, we're not going to look at the last one. So therefore, that is going to give us some of the values that we're going to see here using that application of that acronym. So therefore, I'm going to give this range of values for x still as 0 degrees, 45 degrees, 90 degrees for the value of x, and then we have 135 degrees, 180 degrees, 225, and then we just fill them up as they are appearing along that stretch for the x-axis. So therefore, this is going to give us those specific values. Now in this case, I'm going to just have to find the values of the sine and the cosine of theta and represent them along this stretch as I've mentioned, and we're going to see to what extent, or rather what plot or data is going to be represented in this first part of the graph. So I'm going just to fill in the values. So kindly confirm that the values that I'm going to put here are going to appear or rather not accurate, but it's an approximation to two decimal places, or rather some two decimal places for each part in this particular graph. So therefore, I'm going to have them represented as such. So therefore, from our tables or perhaps the calculators, we can be able to find the values of these two different angles for the two specific trigonometric functions. Now in my case, I've just listed these ones on the board, and these are just approximate values. This is a 7071, and we're going to see that this one can be just represented